think whatever introduction you want to give, please go ahead, and then we can.
Please. So we are really very happy that finally the technical problem has been solved.
Yeah.
And we have our 59th distinguished lecture by none other than Professor A.B. Pandit. So he hardly requires any introduction, but still for the formality's sake, actually we will do it. And before that, what I would like to inform all of you, and after extending a very hearty welcome to all of you who are present and those who are joining from outside. Now, I'm really happy to say so that Indian National Academy of Engineering has entrusted our Bhubaneswar chapter to celebrate National Technology Day in a big way. And we are not able to do it on 11th of May because it's very difficult to get top-notch speaker on that day. But next week, that is from 16th to 21st, in these 5 days, we'll have 4 eminent speakers, 4 top technologists who have agreed to give this lecture, and it will be conducted by 4 institutes of of Bhubaneswar. This university, IIT Bhubaneswar, Niger Bhubaneswar, then IMMT Bhubaneswar, who are all our partner institutions, including ICT IOC Bhubaneswar campus. I hope those things will be very, very interesting, and it will be in 4 afternoons. We'll send all these details once actually the things are finalized. This is just a matter of information. Now, today, the lecture will be given by Professor A.B. Pandit, Vice Chancellor of ICT Mumbai. His topic is Environmental Management, Way to the Era of Sustainability. A short abstract he has given. I'll just read it out. Sustainable development is a dynamic process which enables all people to realize their potential and improve their quality of life in a way which simultaneously protect and enhance the Earth's life support system. This contributed to understand that sustainable development encompasses a number of areas and highlights sustainability as the idea of environmental, economic, and social progress and equity, all within the limits of world's natural resources. Environmental management and sustainable development are 2 intertwined concepts related to methods of meeting human needs without damaging environment. Environmental management focuses on maintaining natural resources such as biomass, water, and open land without diminishing or destroying them. Sustainable development seeks to meet human needs without depleting the resources. There is a growing concern about how to minimize the impact of human activities on the environment. Due to climate change and corresponding environmental and social changes, there is a great need for a more sustainable development of mankind. Over the years, research studies that analyze the sustainable development of different communities with a multidisciplinary approach stress the necessity of preserving the environment for next generation. Therefore, responsible and conscious management of the environment is a pillar of the sustainable development concept. Environmental management is a broad and rapidly evolving discipline. This talk provides overview of the nature, scope, and the role of environmental management with a strong focus on sustainable development. It also explores world's water demand versus population, water footprints, approaches to water management, recent developments in wastewater treatment, biomass, biorefinery concept, solid waste management, agroforestry models. It will also cover some of the initiatives of Ministry of Environment, Forest and Climate Change, Government of India. So this is very interesting topic. So far as Professor A.B. Pandit is concerned, he needs actually no introduction. He is a PhD in technology from Chemical Engineering, UDCT, Mumbai. BTech, Chemical Engineering in Institute of Technology, Banaras, Hindu University. He is fellow of all the academies, including the third world academies. He is Vice Chancellor of Institute of Chemical Technology, Professor UGC, Research Scientist, J.C. Bose National Fellow, and you name any award actually he has. His area of research interest are varied and long. I think our that includes actually physical and chemical processing of applications, cavitation, phenomena, chemistry, and so many other things. Very long list. So he is actually in many committees. Actually, he was there, and he is the fellow of National Academy of Engineering of US, a real prestigious fellowship.
Professor Acharya, I
Third
think,
World of the Science,
Professor
National
Acharya,
Academy
it's
of
okay.
Science.
I think it's enough. Like everybody knows me.
Okay,
all are
okay.
good friends. All are good friends. So let us get started and let's spend more time in terms of discussing and in terms of trying to answer questions.
Thank you so much, sir.
Okay, yeah.
Please go ahead.
Yeah, thank you very much.
I have to say something. That's what I was saying. Nothing else.
That's okay, fine.
Okay.
That's very kind of you to introduce me and giving me an opportunity to say a few words or few issues which we are going to face and which we are currently facing. And that's why this broad title is Environmental Management Way to the Area of Sustainability. We have to sustain ourselves. And to be able to decide that how we are going to sustain ourselves, we need to start with when the doomsday was first predicted. Thomas Malthus, who was essentially a reverend, an economist and a philosopher, put a model way back in 1834, which was, I mean, around that time in 18th century, that he put a very simplistic model saying that if you see the time and the increase in the population is going to increase exponentially, whereas the resources and in terms of exploitation are going to vary linearly or increase linearly. So there will come a point where the population will overcome the resource availability, and that will be the doomsday, after which you will have famine, and that will be something which we call it as end of the world. But that has not happened. The simple reason being the effective utilization of resources has always been governed and shaped by technological innovations. How the minimization of resources can be achieved to get the same objective, energy conservation, water conservation, carbon dioxide capture and recycle, so on and so forth. So technology has always remained a step ahead. And we are currently facing the same situation today when we see that the changes in the climate, the impact of the climate change, and we'll keep on referring to it. Now, if you see Earth, Earth is like a living system. And we all know, those who have had some basic training in biology, that every individual, a biological cycle passes through a lag phase, a slow growth, and then it has an exponential phase. Then that is a stationary phase when the availability of resources start dwindling. And after the stationary phase, which remains as static, the decay phase starts. So if you look at our Earth as a living system, it is expected that we will also follow the same pattern. And indeed, we are following the same pattern. With the industrialization, you realize that we came out of the lag phase. We went into the exponential phase. Now, exponential phase is reaching a top where everything is controlled by the growth rate in terms of GDP without bothering about the availability of the resources. Now and then, time and again, people start talking about the availability of hydrocarbon fuels which are available, but alternatives in terms of solar energy harvesting, in terms of nuclear energy harvesting, things are always going to come up. And we as engineers have to address these particular issues, and we are the people who have created these problems, and we are the people who have to find solutions to these problems as well. So sustainability and a natural capital is essentially is availability of ecosystem goods and services, which is a natural capital, is essential for sustainability. Now, Earth is essentially an adiabatic system. There is no exchange of mass occurs, exchange of energy, only input energy is there, and that input energy and of course the reflected energy goes back. But input energy is in the form of sun, which manifests itself in terms of various natural capital. We use those natural capital which are essentially given by the input energy from sun. Now, over what period that accumulation or what you call aggregated energy is we are putting it all depends upon the rate at which it gets generated and the rate at which we are able to use it or we are currently using it. So this derives the economy. This derives the economic products and services, and that results into availability of all these goods and services which are going to be made available to us. So all the goods and services, the origin can be traced back to the incident energy of sun, not necessarily incident energy of the sun now, but incident energy of the sun which might have been incident on Earth a million years ago or 2 million years ago or 10 million years ago. And we are now harvesting these aggregated energies, and we'll talk about that in detail later on. Now, the linkages of these various resources which we are originating from the incidental sun energy can be looked into in terms of provisioning. That is, we need to provide it for the sustenance of the society. You need to regulate it because we don't want excess utilization. But depending upon your cultural background, is if you consider it's a American way of life, then there are something which are culturally accepted, culturally assumed to be available. Whereas if you consider an Indian way of life, those who come from a rural part or have had experience during their childhood in the rural part and then have shifted to the cities, they know how conservatively and how recyclably we were using our resources and how after shifting to cities, how we have become wasteful, the kind of waste which we are generating, the kind of waste which we are dumping into the society. So all these are the reason for all this is essentially converting ourselves into a feeling of well-being. Now that requires a security, which is personal safety. You know what happened in the Pahalgam just now. Then you need to have resources security and you have security from the disasters. The basic materials for good life, adequate livelihood, sufficient nutritious food, shelter, and access to goods. And health in terms of strength, feeling of well-being, access to clean water as well as air, and good social relationships. See, there requires a social cohesion, the mutual respect, and ability to help each other. But we also have a freedom of choice because if you are considering it's a democracy, then you have a freedom of expression, you have freedom of choice as long as you do not harm somebody else's freedom of choice while executing yours. So these ecosystems and good services are essentially for these three activities: provisioning, regulating, and they are cultural, and they support this entire society as such. But what is the status of our natural capital? Now, there has been a survey which has been carried out by more than 1,360 experts, which is called as Millennium Ecosystems Assessment. And their conclusions are really shocking. Anybody is interested in having a detailed look of that can look at that website, which is given at the end of this particular slide. I'm going to share this presentation with Professor Acharya, and you're free to use this particular presentation. You can share it with everybody. And if they have any questions and details, they can always ask me. This is the current state of our sacred rivers, and I need not elaborate on this. References are also given how they are getting polluted, how we are ruining our sacred rivers in terms of exploitation and dumping of the waste. Water consumption, there has been a huge loss and reduction in the water table. You always see occasionally every 2 or 3 months somebody falling down the bore well, which is 200 meters deep, a bore well of let's say 6 or 8 inches. A child falls in, then you have to drill something else to rescue the child, and many a times the result is not satisfactory at all. You can see 109 kilometer cube in 6 years during a specific period, which is essentially the agricultural water requirement, I mean, water excavated for agricultural purposes. And you see the effect of that in the area of Rajasthan. And for that matter, everywhere else, you will always find that the water table everywhere in India is receding at alarming rate. It also results into soil erosion. And I'm going to come back to this particular effect of the kind of disasters which we are experiencing. And there is a reason for this desire, for these disasters and the increase in the frequency of these disasters. And I will talk about this in later during the lecture. So this is how the erosion occurs. The soil erosion occurs when you have floods. The soil erosion occurs because you have a significant deforestation where the roots are not able to hold on to the soil because roots are not available there to hold on to the soil. Soil gets eroded and the vicious cycle continues. If you look at the anthropological impact of our activities and the ecological limits of our earth, we have these issues: climate change, ocean acidification, stratospheric ozone depletion, nitrogen cycle. Then we have uh, other issues which are there is atmospheric aerosol loading, biodiversity loss, chemical pollution. And the green part indicates that we are okay. I mean, the blue, green part indicates we are okay, and the red part indicates we have already exceeded the limits of the earth, and there is no point or no chance of having to return back to the green part. And you'll see especially biodiversity loss and nitrogen cycle, which have become irreversible because of the usage of synthetic nitrogenous fertilizers left, right, and center. A nitrogen cycle is severely overloaded in the system. Similarly, biodiversity, many of the species have been extinct and we can't do anything about it. And this is where, I mean, ocean acidification is also, some local areas of ocean are severely acidified and others are not. But I think as we talk about the growth of our earth as such, these are not far away. Now, good way to assess this is which is called as an Earth Overshoot Day. Now, Earth Overshoot Day is a concept which was put forward way back in, I think, 2016-17. And since then, every year, these surveys have been put up. This clearly indicates that depending upon the incident sunlight on a country, which depends upon the surface area of the country, the land occupied by the country, what is the extent of renewable resources which can be generated, and what is the rate at which that specific country uses these resources in a year. Now, if let's say Earth Overshoot Day of Denmark is, let's say, March 28, what it clearly means that by March 28, we have consumed the total incident energy which are likely to incident on Denmark over that entire period. But Denmark continues to survive beyond 28th of March. So what do we do after that? We borrow the energy borrow the resources which are going to be from the next year. Then again next year, 28th of March, we borrow resources again from the next year. So what we are doing essentially that we are using resources for which are meant for our children and grandchildren without they having been born and without we asking them about the utility of these resources. In India, before 1992, when India became so-called industrially open and open economy, the India's overshoot day was around 25th, 27th of December. which indicated that we were really living sustainably in terms of incident energy and the total quantum of energy or resources which we are using. Today, the same day is around 27th of July. That means in 7 months' time, we are using an year's resources in India. Now, when the COVID, because of the COVID, that few months of industrial shutdown was there were lots of WhatsApp messages and emails and others, how clean the air has become. You can see the Himalayan peaks from Delhi, and the water has become very clean, the air has become very pure, so on and so forth. What it clearly indicated that if 60, 70 years of abuse on the environment in terms of emissions, in terms of resource exploitation, can be recovered in 2 or 3 or 6 months' time, imagine if the 6 months of lost production was distributed over 60 or 70 years, we would not have noticed it. So the issue which we have to see is don't only go by the GDP increase required, yes, of course, but that cannot be an only criteria for the growth of the nation, which is not definitely going to allow us to sustainably live the way we are currently living. So there are, and we see, if we are surviving, the enterprise has to sustain. That means the industries which are producing our required materials, the agriculture which are going to produce the goods or food which we are going to have utilize or eat. So there are some external drivers and business drivers. External drivers: climate change awareness, government initiatives, rating and labeling schemes. That is, let's say 5-star rating for an air conditioner or a 5-star rating for a fridge, which clearly addresses the issue of energy conservation or energy utilization. Then we do environmental advocacy in terms of recycle of waste, reuse of waste, so on and so forth. And in business drivers, again, creeds and value systems, reputation and branding, shareholder value creation, because shareholders are also looking out not necessarily always for a short-term gain, but also for a long-term sustainable income coming from the shares. So these two contribute to the enterprise sustainability. And of course, a business approach that creates long-term shareholder values by embracing opportunities and managing risk that derive from economic, environmental, and social development. These are based on Dow Jones Sustainability Indices. So you have regulatory compliances. That means you have to do this. Otherwise, you will be fined or you will be penalized. Then you take an initiative of preventing pollution. Then you say that this is a green product, this is a biologically grown product, or this is a greener material, so on and so forth. And that addresses the issue of sustainability. So ecological footprint essentially is ecological footprint of consumption, which is equal to ecological footprint of production plus ecological footprint of import minus ecological footprint of export. Now, when we export a lot of rice or a lot of sugar, in principle, we are exporting a lot of precious water. Right? People do not realize it, that water is not accounted for in terms of its value. But it is part and parcel of the entire cycle which uses water to produce that particular rice. So these are the issues which you really need to consider, whether we can use lesser quantity of water, because sugar and rice, these are the two crops which are essentially cultivated using submerged or anaerobic system of roots, and for that the roots needs to be submerged, but that is not always the case. There are varieties which can also be cultivated using what we can call as irrigated system, is a drip irrigation system, without compromising on the yield. So these type of work which needs to be carried out. Just a comparison. How many Earths would we need if the world population lived like, if all the population decides to live like US, we will require 5 Earths. Like Russia, 3.4 Earths. Like Germany, 2.9, UK 2.6, China 2.3, Brazil 1.8. And India currently, this is 2021, probably we would have gone now beyond 1. So in 2021, it was 0.7. That means we are still living within our means. We are living much more sustainably, mainly because of our cultural, at, let's say, advantage or cultural direction which we get in terms of wastage is minimum, recycle and reuse is always recommended in our practice. So the enterprise sustainability, I've already mentioned it to you, is a long-term sustainability. I think is a repeat here. So if you look at the sustainable shareholder value, everybody is interested in market growth by addressing unmet human needs. That means we have an option available. And for that, you are going to have innovation and product process technology, design improvements, which improves the resource productivity. That resource productivity results into reputation for stewardship and social responsibility. This is a socially responsible industry which is supplying a specific good or an active material. And both these inputs go into meeting the unmet needs of humans. And that is what will derive sustainably the shareholder value. Not just one off that this year the company has done very well, but company has to do every year very well and increase the shareholders' value and availability. And that can only happen if the climate can be stabilized. So we'll get back to this in a minute. So to approach towards sustainability is energy efficiency and eco-efficiency. That means we are usually taught in engineering only energy efficiency. So energetically, as long as the process is efficient, we say that it uses least amount of energy, as a result of which the process is considered to be efficient. We have to look now beyond that, and we also need to look into ecological efficiency. That is how effectively the resources are used. Then we have a technique which is called as a life cycle assessment, cradle to grave approach. We need to consider the byproduct synergy, the circular economy, the biomimicry. Essentially, what it has been advocating is you look at the nature, how nature has survived itself for such a long period and has been sustainably surviving itself. Now, if we can learn the processing, production, and resource generation techniques from the nature, and if we can adopt these particular techniques using our engineering skills, then there is some chance available to us to sustainably keep on producing it. And there is a possibility by considering techno-ecological networks. It is not only techno-economical networks, but it is techno-ecological networks. The techno-ecological networks and techno-economical networks, I will talk about it towards the end of the talk. So just to give you a brief example, is we have a coal-fired power system plant. That is, we are using energy of coal, a thermal energy of coal, converting it into an electrical energy, which is the highest form of energy available. In the process, what we are doing is we are consuming exergy. Exergy is the ability of energy to be utilized to carry out certain work, to carry out certain processes. And that can only happen when there is a gradient available for the utilization of that energy. Whether that gradient is chemical gradient or potential gradient, whether that gradient is in temperature or any other. You need have a gradient to run a process, to drive a process. Otherwise, when everything around is at the same equilibrium condition, nothing gets transferred from one to another unless you create that gradient. So this measures the distinguishability of thermodynamic distance from the surroundings, represents material and energy resources, captures first and the second law of thermodynamics. We are usually taught the first law of thermodynamics in terms of energy and mass conservation, and then second law is usually used to assess the entropy. Many a time the concept of entropy is not clear to many, but exergy addresses this issue of entropy, and I'll talk about it in a minute. So this indicates the difference between heat and work, or forms of energy or types of energy. So exergy can be available in the physical form. It can be in the thermal form. Physical form is essentially potential and kinetic energy. Thermal form in terms of heat value associated with it or calorific value, and the chemical exergy where some reactions are exothermic, some reactions are endothermic. So as the reactions occur, certain energy is released or certain energy is absorbed. So these are the three forms of exergy. So rather than doing energy balance, exergy balance, if done, that will address the issue of sustainability. Mainly because if we may have a large amount of energy, but that large amount of energy does not have any gradient for usage, then that is not necessarily going to be usable for us. Say it's, for example, I consider a big pond which is available in atmospheric conditions, let's say 30 degrees centigrade, 35 degrees centigrade, local temperature is 30 degrees centigrade, the gradient available is only 10 degrees centigrade. As against that, the same amount of enthalpy is available to me in the form of a steam, then I can derive significantly higher amount of energy from it. So the steam has the same level of energy, but it has much higher level of exergy. Similarly, by using about with 40-45% efficiency, the steam is converted into electricity. So electricity has a much higher amount of exergy as compared to, though the energy contents are the same, but higher amount of exergy as compared to the steam. So this is indicated by what is called as a Grassmann or a Sankey diagram, and all these diagrams are available. I'm just indicating. Exergy analysis shows that most loss is in the form of a rejected heat. So when we have 100% of energy supplied by the coal, only 37% of that energy is now available to us in the form of electricity. 56% is rejected heat required because of the thermodynamic cycle which we follow or which we observe in producing it. Now you have cogeneration, we can improve it further. You have, let's say, gas turbine followed by a generation using steam. We can increase that efficiency from 37% to 52%. In the process, we reduce the rejected heat. That means the destruction of exergy, energy cannot be destroyed, but exergy gets destroyed. So the destruction of energy is driving us away from the sustainability. A similar example has been given for a similar this thing. So the analysis can be extended for any activity. Any activity which you carry out can be expressed in terms of exergy balance, not only energy balance. Just to give you a simple example, if you use a heater, an electric heater for taking a bath, energetically it is 97-98% efficient. That is, all the electricity which you put in is effectively utilized for heating of water. But exergy value of that particular geyser is less than 5%. What it means that you are using a good quality energy for carrying out an activity which can be carried out using much lesser quality or inferior quality of energy. Use solar power, solar heated water, good enough. Or if not, then use gas heated, good enough. If not, using coal, good enough. Using biomass, good enough. Why do we waste exergy by using the highest quality of energy which is available in the form of electricity? So one of the simplest of the concept which can be put forward is eco-efficiency is a ratio of value delivered per unit of resource input. And simply speaking, use fewer of the resources, least complicated or simpler processes results into cleaner products and less waste. Less cost associated with fewer resources, also lower investment. Simpler processes means relatively less risk processes. And since the cleaner processes are required, cleaner products are obtained, the purification wastage is minimum. That gives you a greater value. So this is just an example. See the eco concept of water-based primeless auto paints, about 25% reduction in energy and emission footprint, save certain amount for a DuPont. But what it is doing is it is shifting the boundaries. The pollution gets shifted from one location to another location, and that is not necessarily the objective. May not solve environmental problems, but shift them outside the business boundary. So we are okay. We are saving, we are doing things which are more energy efficient, but you are actually shifting the emissions and others to your outside location. You are affecting the environment. Currently, what we are bothered about is the sustainability of the enterprise. What does it involve? It essentially processes and prepares inputs, fabricates and packages the product, and then distributes the product. If we increase the system boundary beyond enterprise, then we need to also look at flow and services, then extraction of the raw material, using that raw material for in the process, fabrication, distribution. Then we have to think in terms of recovery and recycle and flows and impacts on it. So as we keep on increasing the boundary of the systems from enterprise to include life cycle, to include economy, to include ecosystem, more and more data is going to be required, and having an availability of data to decide and to quantify and to suggest quantifiable policies is going to be an extremely complex exercise. But we engineers using a system approach are possible to do that, and that is what is recommended or required at this point of time. So increasing relevance to global sustainability when we are addressing not only the enterprise sustainability, but sustainability of life cycle, sustainability based on economy and ecosystem as well. And as I said, it increases the complexity of the problem. So life cycle assessment aims to consider all processes from cradle to grave, need data for each stage of life cycle, energy, materials, emission, popular and standardized. This is a process which has been used, and this is now has become a standard a topic to be taught at undergraduate level in terms of life cycle assessment. Extraction, production, use, reuse, recycle, so on and so forth. So these are emissions, waste at every stage. You need to find out the quantitative information that to find out its environmental impact on the same. So we study all this, and this is quite a debated issue whether paper bag is better or a plastic bag is better. If you look at it and if you do the analysis based on the exergy, you will realize that paper bag is a much wasteful product as compared to a plastic bag, as long as we have a proper recycle mechanism available for the plastic. Similarly, in terms of fuel, you have a life cycle analysis of corn ethanol versus gasoline. You do the same analysis of it in terms of cradle to grave, and you will come up with quantitative answers which will allow you to make and decide your policy as far as nation availability of resources are concerned. India is shifting from fossil fuel to ethanol blends. Now 5% has become 10%, will soon become 20%. And that again will depend upon what is the source available for converting into ethanol. So we started with molasses. Now molasses has been shifted to sugarcane juice, in some cases even sugar. And now finally, we are now looking into biomass. Now again, biomass valorization in terms of energy. Ethanol is not the only product, because ethanol contains oxygenates, it has a lower calorific value. So there is nothing new about ethanol being used for automobile. Till 1956, all automobiles essentially were running only on ethanol. Only later on we started using petrol or a diesel for our for our mobility purposes. Similar is the case of transportation fuel, as I've just talked about it. You can keep on doing. I've got n number of examples like that, which clearly indicates if you really want to take a choice and make a choice and address the issue of sustainability, you need to look into the life cycle analysis of the entire product to decide. So what are the characteristics of these ecosystems which are getting harmed? Individual processes very efficient. However, every available gradient is exploited to do work, causing overall system to be highly efficient. Self-reinforcing resilient networks are required. All this is mainly with solar energy as an only input. Very much in contrast to the industrial systems, emulating ecological systems may lead to sustainability. That is what I talked about in terms of biomimicry. However, most methods and disciplines ignore ecosystem, and we only look at the growth in GDP, bottom line improvement in the company. We do look at energy usage per ton, reduction in the energy usage per ton, higher selectivity of the products, so on and so forth, but not really look into its environmental impact or ecological impact of our activities. So resource aggregation, I mentioned to you this, is need to aggregate resources to develop matrices and indicators. Mass, mass ignores the fuel value, large mass need not be bad, right? If you are going to use locally the biomass, if you are going to transport the biomass to convert it into liquid fuel or to convert it into pellets, definitely that is going to cost you more. But if you, because it has got a lower calorific value as compared to, let's say, furnace oil or a fuel oil or diesel, energy densities are significantly higher. Here, energy densities are significantly low. But if you use it locally, avoid transportation, then it is definitely possible for you to look at it. So energy focuses only on the fuel value and mainly non-renewables. Exergy captures the useful energy in the material and energy sources without role of ecosystem, that is industrial cumulative exergy consumption. With ecosystem, this environmental cumulative or ecological cumulative exergy consumption. And I'll clear to you about this. These are industrial processes which are using natural resources, resulting into industrial products. You look at the exergy of the input and the exergy of the output, you find out by difference, and you know how much cumulatively you have destroyed the exergy, not energy, sorry, destroyed the exergy. And exergy once destroyed is returned, is destroyed forever. You're not going to get it back. You need to increase this to include ecological inputs as well. That is how much solar energy is put in, which has resulted into production of the resources, natural resources, and that will result into what is called as ecological cumulative exergy consumption. And if you look at it in this way, ECEC, then you are addressing the issue of sustainability. Otherwise, you are talking about the sustainability in a limited sense, sustainability of your industry, sustainability of your product, so on and so forth. So what is resource aggregation challenges? Just to give you an example. Now these two, one is a sweet, a Twinkle or a Cadbury or something like that, and second is 3 bananas. Now in terms of calorific value, both are identical. Both are identical. The equivalent calorific input which you will get if you eat from these 2 pieces of chocolates versus 3 banana are exactly the same. But can we just replace it randomly? That is definitely not possible for us. Both have equal energy content, but quality of this energy is different. They are not substitutable. So need to consider quality and substitutability of the resources before aggregation of comparison. Whenever we compare, we just cannot compare the energy usage. We must also include the quality of energy which has been used to carry out that particular transformation. A joule each of sunlight, wood, coal, oil, and electrical energy are very, very different. And I need not elaborate to a learned audience here. What do I mean by that? So exergy value, they should not be added without quality correction. This is the ultimate source. I have mentioned it in the beginning. I am repeating it again. Considering that ultimate source of energy is solar radiations in different forms, equivalent joules. You remember in earlier days, we used to call it as in terms of coal equivalent, so many tons of coal equivalent. Prior to that, it was so many liters of fish oil equivalent when fish oil was being used as a fuel. Then coal was now then shifted to barrels of oil equivalent in terms of energy. It has been now high time that we must think in terms of equivalent usage of sun incident energy. Right? Everything, if it can be expressed in terms of sun incident energy, then we are really addressing the issues of sustainability. Just to indicate, 10 to the power 6 joules of energy input to plants, to biomass, to fuel, ultimately 10 joules of energy is available for us for usage. That means 5 orders of magnitude reduction in the energy, incident energy to usable energy happens. All our resources essentially are generated because of the incident energy. And now the techniques are available, which is essentially, we talked about energy units are enthalpy, then you have exergy. Again, the units are exactly the same, enthalpy. And now we need to think in terms of energy. Energy is equivalent sun energy. That is what we need to do. And every resource can be correlated. And I'll show you a small table next. This is what I've already talked about. Must consider exergy flow in industrial and ecological system adopted by ecological cumulative exergy consumption. So this is, if you really want to address the issue of sustainability, we need to have first understand the ecological footprint of your anthropological activity. So you have process, you have energy material flow, then we do energy analysis, then we do life cycle analysis, energy of resources, energy of emissions, then that allows you to estimate the ecological footprint and energy materials. You can recycle it, which will, on the right hand side, you will set the regional energy density, assimilation capacity, regional data, local data. What do I mean by regional energy density? See, many times when we import or export, or we move the material or take the material from different location than the manufacturing location, we are using energy, incident energy at some other location and using it for our purposes, for our product manufacture. That also involves the transport of energy, which also uses energy. How much energy is utilized? This is how it is. 1 joule per year to get 1.5 into 10 to the power joules per year of sun energy is required. To have rain or geopotential, 1.04 into 10 to the power 4. Rain and chemical generation, 1.82 into 10 to the power 4. Water taken from local rivers, 3.72 into 10 to the power 4. Is clearly indicating whether it is net topsoil, soil, water used by cement. Every time, in terms of the quality of energy, we are actually using 10 to the power 4 to 10 to the power 5 joules times energy incident on the sun, which has been aggregated over years or even centuries, over eons. Sunlight, same thing, the data which is in terms of solar energy, joule transformation, and this is already I have discussed. So we need to have an energy evaluation. One see from the table, this accounts for every form of energy and resource that can be utilized. And I have already mentioned it to you how much percentage utilized, 10 to the power 5 times less is the amount of energy which we need to account for. But whenever we use energy and want to talk about the sustainability of our enterprise, we always think in terms of what is the cost of input and what is the cost of output, or the sale price of the output, and we get what we call as economical return, or return on investment. Now what we got to call it is EROI, that energy return on investment. So if you are using certain amount of energy for converting a particular product or for making a particular product, and a product is expressed in terms of life cycle, and we get a resultant product. EROI of 10 indicates 10 joules of produce for every joule used in processing. So essentially, if we convert something, we aggregate this particular energy where the product is available in terms of, and this is a classic example of E is equal to mc square, small quantity of mass, significant amount of energy which has been utilized, energy which has been generated. So if we look into EROI should be more than worth for being energetically profitable. We cannot only be looking at our GDP in terms of economic sense if you really want to address the issue of sustainability. So renewability versus thermodynamic ROI, return on investment, you can see what it is clearly indicating: municipal solid waste, newsprint, percentage reliability, and quality of corrected return on investment. What it clearly indicates that the waste has to become a new source or new resource for us to use it. Then only we are talking about the renewability of our systems. Essentially, the waste now should become a new resource, and there have been attempts made in that particular direction, the harvesting of dumping sites, recovering energy as well as material from the dumping sites. So issues are happening, but that needs to look into a totality rather than sort of in a broken way, I mean, sectorial way. So dilemma of renewable resources, difficult for biofuels to provide high return on investment. To get high return on investment, it is best if nature does the work. That is, rather than carrying out a cultivation or having a specific cultivation to generate biomass, where you need to have water being pumped, we need to have water being pumped from the groundwater. If we rely on monsoon, if we allow the biomass just to grow, if the objective is only to generate biomass, then if you allow biomass to let it grow without having it, then that is likely to give you a significantly higher return of investment rather than any planned plantation. Is really a technology savior. There are technological developments commonly expected to lead sustainability. They are. So we have to have look into new energy, fewer emissions. With technology, we can do both. It is not that is not possible. Systems are becoming more and more complex. The data required is becoming more and more. And if we are able to utilize and harness that particular data, it is still possible for us to do that. So the sun has a unique role in sustainable energy production. The solar energy resources additionally far exceeds what can possibly be envisioned as a level of human consumption necessary to support even a most technologically advanced society. Enable humans to use the sun sustainability as their primary energy resource. This is appeared in this. Nanotechnology, there are many these technological developments which are occurring, but they are in isolation. They need to be integrated into systems, and that is what we will talk about it. What does the history of technology indicate? This 1980s, we had horse dung in the street and causing a lot of odors, which was replaced by horseless buggies, essentially cars, which result into Los Angeles smog, then which result into catalytic converters, then result into tetraethyl lead as an additive. Then we had MTB and now ethanol. These are issues with the US, but I have some data available. We have done this exercise for past 40 years of Indian scenario, and all these data we have generated, we have not generated, collected, and we have also predicted how our system or how India is becoming, because of the Western blind following of Western pattern, we are becoming more and more wasteful and forgetting our own cultural tradition of living minimally. Pollution moved across system boundaries and scales from odor to smog and lead. So this is what it was. Yesterday it was like this. Today we are moving horses. Tomorrow I don't know what is going to happen. So can technology lead to sustainability? In my opinion, yes, provided we follow some specific technological directions. Has to play an essential role in enhancing human well-being. However, often you have negative side effects and contribute to ecological deterioration. These effects have appeared as unexpected surprises. Now look at it, everybody understands second law of thermodynamics, that the disorder has to increase, right? The system disorder has to increase. Now, if you are making a product, which means the disordered material, raw material, is getting converted into an ordered product, the disorder has to increase somewhere else, right? And if you consider Earth as an isolated system, the disorder has to increase where? In the environment. And what you see is the impact of climate change, the floods, sometimes the droughts in other places, unpredicted rain patterns. This is all essentially unexpected outputs. The increased chaos or increased disorder into environmental system when we try to bring more, when we try to make more and more product, that means try to bring in more and more ordered into product, the disorder outside has to increase, and that is what gets reflected into unexpected surprises. Can it be avoided in the future? In principle, second law says creating order in the system must result in greater disorder in the surroundings, and that is what we see. Disorder appears in the form of environmental impact. So I just said, gave an example, and business and technologies aim to create order must result into environmental impact. Does it mean that if environmental impact is inevitable, can any technology be clean or green? Can any technology lead to sustainability? Can the second law be violated? Answer is no. The only thing what we can do is follow as the nature does. If we have already used one system and we keep on looking at this particular cycle of it, consumption, decomposers. So this, I think everybody has looked into the life cycle in terms of various resources, waste, food material, completely recycle. Recycle is as much as possible. Mimic the nature in terms of your transport processes, in terms of your processes used for the product making as much as possible. So individual processes are not very efficient. However, every available gradient is exploited to do work, causing overall system to be highly efficient. We have already discussed this. I think there's some duplication. This is what waste is equal to food is equal to value equal to profit. Now this can be mined. Now there are specific techniques available for mining of the dumping sites, and people are already making a profitable business. And all these people who control the dumping site, you see the kind of earning which they have. They earn much more than the people who are actually involved in honest practices. So the network of industrial systems, essentially, I'm just giving to you a couple of simple examples and I will stop. You have a power plant with the input is coming coal and water and oxygen, results into sulfur dioxide, CO2, warm water, and of course electricity coming out from it. And then it also results into limestone, calcium sulfate, goes into a cement plant, warm water can be added out there, and again warm water and CO2 comes out. Now the cement is used in a concrete block. Some of the ash from the power plant can be added. You are trying to get some sort of a network where the output from one activity can become an input for the other activities. How would we do it if we want to include the environment and use this particular activity to reduce the environmental impact? You can do that. The network of industrial system, very similar. Concrete black plant, I've already said that. Can I use this particular CO2 which is coming from power plant and CO2 coming from cement in terms of increasing the forest systems which emits oxygen and can use that particular oxygen to drive the combustion air, providing the oxygen which is required for combustion air? Can I also use that water which is coming out from the cement plant to construct a wetland, to develop a wetland and a river ecosystem and provide that water for the power plant? I can also use that particular fuel. What you see out here is I can use that algal systems, provide a biomass, nutrients, sun, algal ecosystem, and all these. What I'm doing now is rather than limiting myself to industrial network, I'm now also adding ecological possibilities, and I'm now considering industrial ecological network to address the issue of sustainability. Now, this is a very busy slide, but this is how the complex system is. System is extremely complex, the data required for it. So the real challenge for the network of industrial ecosystem design is to get correct data, to think very innovatively, to consider the first and second law of thermodynamics simultaneously, and we will find solutions to this. So these are the challenges which we have in network of industrial ecosystem designs. Industrial systems are well understood. Ecological systems are not well understood and designed by self-organization, need to integrate significant available knowledge about industrial and ecological system, must also consider economic aspects, result in a complex network, need to utilize understanding about complexity, need to design policy that will encourage adoption of network of industrial ecosystems. And this is an extremely fertile area for process system engineering. So these are the challenges in NI's design. Importance of social economic factors. There are multiple options available. Carbon taxes already coming in. There are challenges of sustainability. Can technology lead to sustainability? Engineering focus on enhancing efficiency need not translate into less resource use, which is called a Jones paradox. In US, they decided to improve the efficiency of the car, our car for driving purposes, so that the fuel utilized by the people will be less. Because now instead of running 10 kilometers per liter, you are running 20 kilometers per liter. But that resulted into exactly opposite. Why? Because people found that now we are using lesser fuel, because then we can travel longer, we can travel more distances. And in fact, because of engines being made more efficient, the objective was to reduce the fuel consumption. Because people started traveling more, in fact, the energy consumption of fuel consumption increased. So when you do something like that in terms of a policy decision, you need to look at this paradox which has happened. So these are the issues related to carbon tax. Nothing is simple. Nothing is simple. So these are the interactions between economy, prices of raw materials, different industrial operation, cost of the product, final demand, and this results into. So challenges, traditional reductionist paradigm is not enough, needs to be combined with a more holistic view, learn from ecological systems and account for their role in supporting industrial activity, must also consider socio-economic factors, educate a new generation of engineers, and that is why the issue of sustainability and sustainable designs is not an afterthought. It has to be integrated into every curricula, and basically every practice of design which you suggest or which you teach in the class needs to be coupled with the sustainability of that particular design. What is the impact of this particular design on the environment needs to be looked at. So the significant problems which we face cannot be saved or solved at the same level of thinking we were at when we created them. Right? So yes, but not via current engineering paradigm. Technical challenges must consider life cycle, identify improvement, economic challenges, social, cultural, legal, many issues, but process system engineering has the ability to translate that. I would like to acknowledge Professor Bhavik Bakshi, as well as a couple of my collaborators with whom I have relied significantly on deriving this. So thank you very much for your patient hearing, and I'll be more than happy to answer any questions. Thank you.
Thank you, Professor Pandit, for your excellent lecture. And it opened definitely new new ideas and new way of actually thinking for sustainability. So now
Each of these, see, there is another lecture of mine which I'll give you at some other point, which I call it as a progress and nature. So we always aim for progress, but without considering what is its effect on nature. So which is again very similar to what I just talked about.
Okay. Thank you so much. We will look forward to that lecture also.
Pleasure.
Now, may I request to raise any type of question?
Any queries, questions which you may have, I'll be more than happy.
Yes.
I think I'm among the elite group of engineers, all are fellows, so I'm very happy. And they have definitely certain queries, questions, or maybe corrections to what I have said today. And I really look forward to that.
Sir, can I ask a question?
Of
Am
course.
I audible?
Yes,
Okay.
you're audible.
Sanat Kumarji, please.
My name is Sanat Kumar. I'm a BE Mechanical Engineering.
Yes.
So rather limited in entire intellect. But anyway, I have a question which is maybe philosophical and certainly speculative.
Yes, sure.
I am one of those people who are against the use of air conditioning anywhere, because I have learned that it puts the heat back into the atmosphere. Up to that I got it.
Absolutely. Correct.
So now, what you said, that the entropy, that is wasteful use.
Yeah.
We are letting off into the environment. That's what you said.
Yes.
Yeah.
Yes. Yes.
Now, I look upon our entire environment as our atmosphere, which is only about 10 kilometers out of the Earth radius.
Correct.
Beyond that, our atmosphere doesn't exist.
Correct.
So
It is
therefore, now
isolated. Our system is isolated. Yeah.
that's right. So now I am trying to see whether I'm speculating. I understand that I'm speculating. Is there any, do you think there's any time, any possibility of letting this disorder get into the vacuum of the space? And maybe that way we will not have environmental impact immediately on the earth that we are having. And there may be a possibility that wasteful energy that we have left into the space has become usable and gets back to us. After all, the sun gives only a very limited amount of electromagnetic radiation. It doesn't give too much. So, is there any way you think it can be done like that? I
Okay.
know it's very speculative.
Let me try to answer that if I understand it correctly. See, the radiations which come from the sun are essentially in the shortwave category, right? So basically, ultraviolet, medium, and some infrared, right? Because of the temperatures. Whereas the radiations which are coming from the Earth's surface in significantly low temperature are long wave radiations. Shortwave radiations can pass through the atmosphere, but long wave radiations cannot. So once your system is heated, the diffusion of heat which is going to take place, and what you are saying is let that excess heat be sent out into the atmosphere. What it requires, yes, it does require and it will happen. But the rate at which we are putting it in and the rate at which it is going to go out is so different that you require a significant gradient which is available for
Sir,
that heat.
gradient here is available in the form of pressure. For example, the
No, no,
space
but
is
then
vacuum and we have atmospheric pressure.
you are forgetting gravity, sir. Then our atmosphere is held because of the Earth's gravity. Atmosphere is held by the Earth because of its gravity. Now, when you say gradient, yes, of course. If you go to space, when you are facing sun, the temperatures are going to be in excess of 200, 300 degrees centigrade. In shades, the temperatures are going to be minus 70 degrees centigrade. And that's exactly what happens. That at some locations where there is a night where the heat dissipation will take place, but the other part is getting heated. So wherever you have industrial activity, if it is well distributed, but that is not the case. What we have is there are pockets of industrial practices where the hot airs are being generated, hot gases are being generated. You move away from it, it's not such bad thing.
Okay, sir. Thank you. Yeah.
Thank you.
Okay, I got it.
Any other question?
Yes.
Mr. Sahib would like to ask some questions.
I have some question.
Please.
Dr. Pandit,
Yeah.
can you hear me?
Yes, of course.
It was excellent exposure. This is DP Mishra. I am speaking.
Yes, I recognize your voice, sir.
Yeah. And so I was just wondering, what will be the latest definition of environment? Because if I take to Gita, Bhagavad Gita, the 5 gross elements, Bhumi, Rapo, Nalo, Bayu, Bhumi, Apaha, Anala, Bayu, and Khong. Khong is sky. These 5 are the 5 gross elements from where we are born and from to where we will go. So now, what in the latest definition of environment that we are discussing, what is the latest definition of environment? I think that in my the imagination, all these 5 elements belong to the environment.
Indeed. Indeed,
So,
they do.
So what the God has given us, these 5 environments fresh.
Yeah,
We are polluting that and suffering from climate change.
absolutely, sir. Absolutely correct. And that is happening. That is happening because we are polluting the environment at a local level. Right? Many a times when you say, when you come to city, you have bad air, you have AQI very high in the worst category. You move out where there is not much industrial activity going on, and you find suddenly the air quality is much better. You feel better. So what it essentially means, if you have a distributed anthropological activities, you will not notice the changes which are taking place. This is point number one. Point number two is we are only bothered about the growth rate in terms of economics. We are not bothered about its environmental impact, its sustainability issues. So the issue needs to be looked in holistic way. That is why I think, since we have already used up the material and so much of junk is available, so much of waste is available, can that waste be looked upon as an alternative resource? Because that is definitely going to help us, because we have actually emitted something. Can that emissions be taken back? So CCU, carbon capture and utilization concepts which we are talking about, is indeed very laudable. But we need to come out with the technologies and devices which will make it economically viable as well, on the current practices and on the basis of current values or current, let's say, costs associated with it. But if you look at the earth as a whole, then the material balance has to be there, right? Carbon balance has to be there. But what are we doing? We are converting carbon from solid form into gaseous form, or carbon from liquid form to gaseous form. Now, once you go into gaseous form, then essentially the passage, because the infrared absorption is going to be significantly higher, and that is increasing the warming. The warming will increase the evaporation. So your rains will also improve. I'm not denying that. But the rains will be not necessarily be distributed the way it was getting distributed earlier. And that is why sometimes you feel that there are absolute downpours in some location and it doesn't rain anything for months together. So these are the issues which are very local. On a global scale, we may not. But there are areas where there is nothing else and nobody is living there, so they don't talk about it. Whereas we are living here, we are the people who are creating it, so we will talk about it. Hegde sir.
Yeah. Dr. Pandit, very nice to hear you, such an excellent presentation you made.
Thank you.
And you know that I'm from the built environment, basically from the construction industry. And according to my calculation, almost around 52% of the carbon dioxide emission in India, carbon footprint in India, is because of the construction industry. That's what my computation shows that. And again, out of it, and I've done some calculation, 90% to 95% is because of cement and steel together. Cement and steel together.
I completely agree with you. I completely agree with you.
Even in built environment, out of 52%, 90 to 95% is because of the cement and steel together. And again, I tell you, Professor Pandit, it's very interesting. Majority of cement and steel production, again, it is because of the energy consumption out of the fossil fuels which has been
That's true.
which has been used. So ultimately, we come to that what you have spoken so eloquently is to the energy. What I feel is completely it's depending upon the energy. Of course, you spoke so eloquently about the circularity concept also. Whatever the wastage which is going, I think our industry is trying its level best to replace this OPC with ordinary Portland cement. When I say OPC, with the wastages, like so many other, you are aware of
Yeah, I
it.
think
Yes,
many of the cement industry are now, whichever has a
yes,
reasonable calorific value, they don't mind burning it in their
yes, yes.
rotary kiln. As
Yeah.
long as it doesn't introduce certain specific gases, they are okay with it.
Yeah. See, my question is, you see, the thing is, all of us are aware, as you rightly said. You see, the thing is, carbon dioxide is emitting when cement is produced and the steel is produced, and we are aware that the CCUS is one of the very best ways of going about it. And we know that we have the technology of the CCUS also, carbon capture, utilization, and storage also. And also, I think. I think you have been also working on that green hydrogen. I think that green hydrogen can be used in the production of the steel itself as a
Yes.
DRI,
Yeah.
whatever it is.
Yeah. Yeah.
So I think we know all these things, but only because it is uneconomical,
That's it.
most of the industrialists are not going for it.
Hello.
How to make it realize, as you rightly said, it's not the GDP. This
Uh,
is an indicator of finance,
yeah.
economical indicator. It is
Yeah.
not just the economical indicator, and it is also this, like this technologies, even though it's very expensive, it has to be mandated by the government. No, you've got to go for it and you'll have to use it. Why it is not happening? What do you think is the
I
problem?
think
We
it
know,
is.
we know the technologies. We know the
No,
technologies, but
see,
it's
I
not
think
happening.
this. Yeah, this will happen, Prof, when we raise a standard of living of the overall to a certain level. This will definitely happen. And in smaller ways, things are happening because now DST has a CSR has put up I am chairing that where CCUS specifically for cement industry is being done. Four big projects totaling to about 200 crores are currently sanctioned, where one industry, two labs are now coming up with technologies, combining it with cement industry, where the cement industry will actually adopt it and put it in the pilot plant and test the technologies. So on large scale, this is happening, and this will happen. But I think we require a certain level of say financial maturity or financial wellness for average people who understand these particular issues. So once we start developing that understanding, these things will happen. Is as you correctly pointed out in steel industry, Tata Steel is now going for it. Is they are going to use hydrogen. I mean, rather than coke based refining of iron ore, you go
Yeah,
use do the carry out reduction using hydrogen directly. So
correct.
these things will happen, and I think as more and more people will enter into it, the costs are going to reduce. I'll give you a specific example, simple example. Now government of India has opened up the nuclear sector for uh, to the private
Yes.
Small,
enterprises.
yeah,
Yeah.
small nuclear plants. Yeah,
Yeah.
SMR,
No,
SMR.
there are three basically: small, medium, and micro. All
yeah,
three, right? Small essentially is aiming for replacement of all the thermal power plant when they age out. You will have a small nuclear reactor, 200, 400 megawatt kind of an order. Then medium scale would be up to 30, 40 watts or so, and micro 5, 10, 15 megawatt or so. If you look at this particular issue of this, now they have opened it up. Now, if you calculate the cost of let's say for 40 megawatt reactor, if you import it, it is going to cost you 200 crores,
mm,
right? So about 5 crores per megawatt hour, which is still less. Or in fact, even 10 megawatt imported, nobody will import 10 megawatt, but if you want to import, it will cost you about 150 crores or so. As the scale increases, per megawatt cost goes down. But if you have a technology, designs are available, designs are being developed, and if Indian fabricators will get into that, the same reactor will be available at 1/5 the cost.
yeah,
You look at everywhere. Why ISRO has been so successful? I think the ISRO has been developing uh, rockets and satellites at a fraction of the cost of the Western world. So we have that capability. Just a question of let that Indian, I would say, innovation animal be let loose and provide them the necessary funding which is going to be required. Things will definitely happen, and I'm 100% certain that if we are our zero carbon zero by 2070, I don't think we are going to wait till 2070. By 2050, we will definitely have zero carbon economy.
Thank you. Let's hope for the same. And I will certainly requesting you. I'll be requesting your presentation in PDF form. I'll be writing an email to you.
Yes, I'll share it with Damodar Acharya Sahab immediately.
We will send you, sir. We'll send you. No issue.
Yeah. Thank you.
Dr. Pandit,
Yes.
you said CCUS, in India, we are yet to have one installation on CCUS. What you said that there have been 4 installations have been sanctioned or something like that?
Sanctioned, yes. 4 installations have been sanctioned, and they will with a time span of 2 years for implementation.
Where are they going to be?
I don't remember the numbers, but I think I can share with you later on.
Yeah. Because in the thermal power plants, where in Western world the CCUS has already been there.
Yeah, it is there. It's there. In fact, you're absolutely right about it.
Yeah, I was in Canada in 2017. By that time, Saskatchewan power plant.
Saskatchewan pilot plant. Power plant.
They had CCUS.
Yes. Now I'll share those. I don't remember, but there are 4 projects which have already been sanctioned.
Oh, that's a very good news.
Yeah.
In fact, I was involved in the coal to oil feasibility study. There we were putting the CCUS, and the cost was about 25% of the process plant was the cost due to CCUS actually.
Correct. And that's what I'm saying. See, we have to look at the existing industries, and that's why I said industrial network is important. You can start new things, but already existing industries which are polluting industries, can these industries be integrated with something else which will result into a second product formation? The exit or emissions coming from one industry, can it be considered as an input raw material for other industries?
Correct. Absolutely. Thank you very much.
Thank you very much.
Any other question? No, sir, I think there is no other question. So, Professor Pandit, actually it was a great lecture and we all enjoyed this one. So, thank you very much. And
thank you very much. And I appreciate your patience.
I must really thank you for your this thing. Yeah. And one thing that I would like to mention that we can, as you know, actually INA, what is this condition? So definitely we'll send you a small memento. Maybe I will hand it over to your this thing, or I will send it by post.
No, you can. No, don't bother to send it by post. When I come to Bhubaneswar next time, I'll meet you.
Yeah, Dr. Damodar Acharya ji, I think you have been
thank you, friends, actually planning this beautiful lecture.
You can keep it when I visit Bhubaneswar next time. Probably in a month's time, I will meet you at that time. I'll collect it from you.
Sure. You please also please join actually the lecture which Professor J.B. Joshi is going to give on Monday.
I know.
And
when is that lecture?
That is on Monday. I'm yet to get his title, etc., so that I possibly will send it to circulate it. So,
Dr.
Pandit, I will also request you to remind him. He might have forgotten.
I will remind. I'll be meeting him tomorrow, so I'll remind him that.
Dr. Acharya.
Okay.
I must congratulate you. You are doing a wonderful job
Absolutely.
in having these lectures. No other center is doing actually.
No, it is all actually
See,
blessing of
actually,
many
I think
people.
who
It
can
encourages
refuse?
us.
Who can refuse
And-
Professor Acharya? That's the issue, you know. Nobody can refuse it.
my sister institutes are actually they're really contributing a lot. They are helping
And
with all their encouragement. It is coming up.
And I don't know whether you know, today we lost a great scientist.
Yes,
Dr.
yes, I think it is
Kasturirangan.
Kasturirangan. He passed away today morning at 10:45 a.m.
Mhm.
Right.
I see. I see. I see.
No, I missed. Which name, sir, you said?
Professor Kasturirangan.
Oh, God.
Chairman of ISRO. He
Today
was the
morning, chairman of ISRO is one recognition, and the chairman of National Education Policy is another introduction.
He was
No,
in
he is actually a great person.
he was in
Absolutely.
INAE also. He was in INAE.
Ah,
Yeah, he was a president.
Candidate nomination.
how old he was?
Candidate
84.
nomination member.
Very nice.
so, sir, thank you, all of you.
Okay, thank you very much. Thanks a lot.
And I'm
Thank you.
sorry for the trouble that whatever we had.
No, I think the trouble was at my end. I don't know.
No, nothing. It happens.
Yeah. So I knew that, and that's why I purposely made my assistant make a link and let me try it out. I tried everything, worked out, but I don't know what happened this time.
No, it's okay.
Anyway, that's fine.
It happens sometime. Nothing you can do.
Okay.
Sir.
Great.
Okay,
Thank you.
thanks.
Thank you. Bye.
Thank you. Thank you very much.
Thank you very much. Namaskar.